A radioactive sea of magma hides under the surface of Mars. The discovery helped to show why the red planet's core is not as large as earlier estimates had suggested it might be. In 2021, it seemed as if Mars had a surprisingly big heart. Scientists had been using InSight, a robotic lander, to study the planet's insides. The spacecraft had listened to enough Marsquakes to develop a picture of the layer cake nature of the Martian underworld. The crust and mantle were not especially strange. The core, however, was too large and not very dense for such a small planet. For some researchers, that core measurement didn't ring true. "We missed out on something," said Amir Khan, a geophysicist at ETH Zurich in Switzerland who has studied InSight's data. "But what?" "It turns out Mars's core is small after all," Dr. Khan and other researchers have found. In two studies published Wednesday in the journal Nature, researchers re-evaluated InSight's seismic record. Both teams independently concluded that Mars's core is more like our own world's heavy metal heart than previously suspected. The initial higher size estimate was a result of an undetected 90 to 125 mile deep ocean of molten rock, which made the underlying core seem bigger than it is. But the deep sea of magma, hidden below Mars's solid mantle and kept molten by radioactive elements, is exotic. It does not exist on Earth, Dr. Khan said, and its presence may require a rethink of the red planet's chaotic evolution. Scientists have studied Earth's geologic layers for more than a century using the illuminating power of quake-made seismic waves. InSight, which landed on Mars in November 2018, was sent to find if the rusty world's viscera were similar. But studying Mars with a single seismometer proved difficult. InSight's instruments detected only a few modest tremblers that came mostly from a convulsing region close to the spacecraft, and only a small slice of the Martian pie was seismically imaged. For some time, Marsquakes also seemed to bounce off but not plunge through the planet's innermost sanctum, revealing precious little information about the core. Researchers worked out that Mars's core had a radius of about 1,140 miles, suggesting it wasn't very dense. Terrestrial planet cores should be iron-rich, but the puffy Martian core, eventually confirmed to be fully liquid, seemed 27% lighter than one made of pure liquid iron. The implication was that Mars's core was strangely enriched in lighter elements like sulfur, carbon, oxygen and hydrogen, nebulous matter that the young sun should have blown away before Mars formed. Puzzled, scientists hoped a stronger seismic yaw would provide clarity. And on Sept. 18, 2021, the firmament delivered. A meteor careened into the hemisphere opposite to InSight, screeching out seismic waves that blasted through the core and ricocheted around its edges. "That was the turning point," said Henry Samuel, a geophysicist at Université Paris and an author of one of the new studies. Based on a model of Mars's thermal and chemical evolution, Dr. Samuel and his colleagues had proposed the existence of a core straddling magma ocean in 2021. "But we had no seismological evidence," he said. With that meteor impact, his team confirmed the existence of this superhot radioactive soup. Dr. Khan's team also leveraged the impact to re-examine InSight's seismic data, combining it with computer simulations that explore how iron-rich alloys behave on a molecular level, and, in doing so, independently found Mars's hidden magma ocean. Its existence means the liquid core's radius is closer to 1,000 miles, a denser, iron-rich orb with fewer lighter elements, which is easier to explain. "The discovery is very cool and the study's shared conclusions are convincing," said Paula Kolemiger, a seismologist at Oxford University, not involved in the research. "But they might open up a new problem. Before it collapsed 3.8 billion years ago, Mars had a magnetic field that shielded its atmosphere. Scientists thought the magnetic field was generated by a cooling, and thus vigorously churning, liquid iron core. But a radioactive, magmatic blanket swaddling it would have kept the core too toasty. So a new origin story for Mars's magnetic bubble is required." Dr. Samuel offered one suggestion. Perhaps long ago, Mars possessed moons more massive than its present-day Lilliputian pair, the sort whose strong gravity could stir up magnetism making motions in the core. But for now, he said, that is just a hypothesis. After 4 years, InSight died in 2022. But the discovery of this magma ocean probably won't be the mission's final surprise. This is just the beginning, Dr. Samuel said. NASA releases first detailed map of the insides of Mars. NASA's InSight mission revealed Mars's inner workings down to its core, highlighting great differences of the red planet from our blue world. The fate of almost everything on Earth's surface is determined by infernal engines deep below. Mars is no different. Now, thanks to an intrepid robot parked on the Martian surface by NASA in November 2018, scientists have a map of our neighboring world's geologic abysses, the first ever made of another planet. NASA's InSight lander has been listening to Marsquakes and tracking their seismic waves as they journey through the planet. A trio of papers published Thursday in the journal Science, using data InSight has collected, reveals the red planet to be something like a colossal candy treat imagined by a ravenous deity. Its crust is split into 2 or 3 layers of volcanic chocolate. The mantle below has a surprisingly sizable and rigid toffee-like filling. And the planet's core is surprisingly light, less nougaty center, more syrupy heart. Paired with recent activities at the surface by new NASA and Chinese robotic rovers, these missions highlight stark differences between our blue world and the red one next door. This survey of the Martian insides has been a long time coming. Earth's solid but squishy mantle was first glimpsed in 1889, when seismic waves from a quake in Japan dove in and out of the layer before emerging in Germany. Earth's liquid outer core was discovered in 1914, and the solid inner core was revealed in 1936. Similar measurements of the moon were made when the Apollo astronauts left seismometers on its surface. Now the same basic and foundational measurements have been made on Mars. This work, conducted with one of the most technologically advanced seismometers ever built, represents a major leap in planetary seismology, said Paula Kolemiger, a seismologist at Royal Holloway, University of London, who was not involved in the research but co-wrote a perspective article in Science. Earlier missions to Mars have provided rough estimates of the dimensions and properties of its innards, but InSight's seismological surveys provide precision. Models used to simulate the evolution of Mars can now be built on the foundations of these ground truths. Revelations from the InSight mission will also be useful for studying other worlds by providing scientists with an example that differs from Earth. If you're a doctor and you only practice on one patient, you are not going to be a very good doctor, said Mark Panning, a planetary seismologist at NASA's Jet Propulsion Laboratory in Pasadena, California, and a co-author on all 3 papers. Mars is more like a cousin of our planet than a sibling. 6 times less voluminous, it is strangely small, and geochemical evidence suggests that it's this really ancient relic of the early solar system, said Christine Hauser, a seismologist at the Earth Life Science Institute in Tokyo who was not involved with the research. Why is diminutive Mars so physically different from Earth and Venus, a planet thought of as Earth's geologic twin? InSight's forensic examination improves scientists' chances at finding an answer and, in the process, better understanding our planet's place in the solar system. Over the past 2 years, the InSight lander has studied the red planet's magnetism, its wobble as it orbits the Sun, and the seismic waves created by its Marsquakes. Most Marsquakes occur at shallow depths, but a handful emanate from deeper locales, ricocheting through the planet before reaching InSight. Seismic waves change speed and direction as they traverse different materials, so scientists could use these deep-seated quakes to see what's going on inside Mars. It hasn't been easy going. Working with a solitary seismometer means scientists get a decent look at just one region on Mars rather than the entire planet. And, to construct a detailed picture of the subsurface, plentiful powerful quakes that pass through much of the planet's depths would be ideal. Unfortunately, Mars's seemingly infrequent quakes are never more potent than a magnitude 4.0. We just had to push forward and see what we could do with this data, said Bridget Knappmeyer-Endrun, a planetary seismologist at the University of Cologne and lead author of the paper on the Martian crust. Despite the challenges, the team managed to make a detailed X-ray of Mars's guts. Scientists confirmed that the crust is thicker in the southern highlands and thinner in the northern lowlands, where ephemeral oceans may have pooled long ago. On average, the planetary crust is between 15 and 45 miles thick. It is also split into a top layer mostly made of volcanic rock shattered by meteorites, a middle layer of more coherent volcanic rock, and, perhaps, a lower layer whose properties cannot be made out for the time being. Like Earth's, Mars's mantle is far thicker than its crust, but the rigid part of the upper mantle, which on Earth forms the base of ever-shifting tectonic plates, is perhaps twice as thick on Mars, maybe more. This might be the simple explanation why we don't see plate tectonics on Mars, said Amir Khan, a geophysicist at E.